Good evening, everyone. Hello, my name is Parker Beard, and today we will be learning about electron configurations. We are all made of cells, each and every one of us, and the notation for keeping track of the locations of every electron in an atom is called an electron configuration. Electron configuration is defined as the distribution of electrons of an atom or molecule in atomic or molecular orbitals. Electrons are attracted to positively charged protons, so the electrons attract towards each other. But electrons cannot be near each other, so they repel in patterns around the nucleus. These patterns are called orbitals. The Pauli exclusion principle states that in an atom or molecule, no two electrons can have the same four electronic quantum numbers. As an orbital can contain a maximum of only two electrons, the two electrons must have opposing spins. This is explaining that two electrons cannot be in the same place at the same time. All of the electrons want to be close to the nucleus and create a balanced atom. Only a certain amount of electrons can exist in each orbital depending on its size and location in the atom. The distance an orbital is from the nucleus is called its energy level. The type of orbital determines how many electrons can fit inside. The three types of orbitals are orbital s, orbital p, orbital d, and orbital f. I know I said 3, I mean 4. Please forgive me. Orbital s can hold 2 electrons. Orbital p can hold 6 electrons. Orbital d can hold 10 electrons. And orbital f can hold 14 electrons. The energy levels go level 1, level 2, and level 3. The electron configuration for oxygen is... Hold on, let me get in close. 1s2, 2s2, 2p4. The letters show what orbitals are available. The big numbers show what energy level orbitals are in, and the small numbers show how many electrons are in each orbital. So the letters will show what orbital it's in, or what orbitals they're in. The big numbers show what energy level they're in, and the small numbers show how many electrons are in each orbital. The number of electrons equals the number of protons, so the small numbers will add up to the atomic number of an element, or in this case, 8. The easiest way to make electron configurations is using an electron configuration table. I'll show you that in a second. Once you have this table, you can follow the arrows and distribute electrons to their energy levels until you have used all of your electrons. Every electron configuration follows this format: a number, a lowercase letter, a number in superscript. Let me demonstrate again with argon. And while I'm at it, I'll show you what an electron configuration table looks like. This is an electron configuration table. You can move down, and so you start with 2, you go 1s, and then you go 2 and it's 2s, and then it starts at p and that goes to 4. So you go, or it goes to 6, so it's be 2p6, unless you have less electrons, which I'm going to show you right now. This is argon. It has 18 protons and electrons. So the s orbital holds 2, so it's 1s2, 1 meaning it's in the first energy level. And then 2s2, which means that second energy level, and the orbital is s, which holds 2. And then it jumps up to p, so 2p6. And then 3s2, because it goes back, if you look right here, and then 3p6 right here. So, I hope you found that very educational. I will be glad to answer any questions, and I hope that you have a great rest of your night. Thank you so much for listening. My name is Parker Beard. Peace out.